Hello friends, welcome to my YouTube channel. Friends, today we are going to discuss the Buckingham equation to account for the dynamic load in gears. That is to estimate the actual force which is present between these two of the two gears, the mating gears, which is responsible for power transmission. That is, we have to account that force, that is, we have to estimate that force which is responsible for power transmission between these two gears by using Buckingham equation. Okay, so friends, let us see this. Now friends, see this. Suppose gear A is driving gear B and it is transmitting power to gear B. Okay, and the tooth of gear A is making contact with the tooth of gear B in this process of power transmission. Hence gear A is driving gear here, which is rotating clockwise, and the tooth of gear A is making contact with the tooth of gear B. Okay, and as a result power is being transmitted to the tooth of gear B, and gear B is rotating in clockwise direction. Okay, so tooth of gear A, this is the tooth of gear A and this is the tooth of gear B, and tooth of gear A is transmitting power to tooth of gear B. Okay friends, now friend, in this figure we can see that because gear A is driving gear and gear B is driven gear, and the tooth of gear A is making contact with the tooth of gear B, so there will be a force which is acting between these tooths and which is denoted by P. Now this force P is being resolved into two components. One is PT and another one is PR. Here PT is the tangential component of the force and PR is the radial component of force. These two components are obtained after resolving the force P into two mutually perpendicular directions. Now friends, let us see two cases. The case number one is when gear rotate at very low speed, almost equal to 0, then the tangential tooth load or the tangential component of the force is the actual force present between the tooths which is responsible for power transmission. Why? Because this PR, that is the radial component of the force, is inducing only compressive stresses. It is not responsible for power transmission. Only PT, this PT is responsible for power transmission at low velocity of rotation of the gear. But when the velocity of rotation of the gear is very high, then the actual force which is transmitting power between these two gears is not equal to PT. It is somewhat greater than PT. Okay, and this is because of the reason that there are inertia effect, that is because of the mass of the gear A and gear B, there are some dynamic forces which will also add to this PT, and there are material properties of the gear are also there, such as the modulus of elasticity of the gear and the pinion are the material properties, and error in gear machining will account for increase in this actual force which is responsible for power transmission. That is, the actual force will be higher than this PT, and which is because of these dynamic effects. And to include these dynamic effects, we will use Buckingham equation, that is to estimate the value of actual force which is responsible for power transmission at higher velocities. We will use Buckingham equation. Now the actual force at higher speed of rotation is given, which is responsible for power transmission, is given by CS PT plus PT, where PT is the tangential component of the force and CS is the service factor and PD is the dynamic load or incremental load. So the actual force which is responsible for power transmission at higher velocity of rotation of the gear is given by this formula, and whereas for the lower speed of rotation the actual force was given by this formula, which was responsible for power transmission. So the actual force responsible for power transmission at low speed of rotation is given by PT, and the actual force responsible for power transmission at higher velocity of rotation is given by this formula. Here we have included a term PD, that accounts for the dynamic effect which will arise because of all these reasons. Dynamic effect of the loading which will arise because of all these three reasons. Now friend, this dynamic load PD is given by Buckingham using this formula. This is called the Buckingham equation. So this dynamic load or incremental load PD is equal to 21V, where V is the pitch line velocity in meter per second. Okay, and this C is a constant here, okay, which is called as the deformation factor, and here K is a constant, and also friends, here K is the constant, and E is the error in the gear machining, sum of the error in the gear machining, and B is the phase width of the gears, and PT is the tangential component of the force, which is given by power divided by velocity, that is the power being transmitted between these two gears divided by pitch line velocity of either of the gears, okay. And E is here is the sum of the error between the two mating teeth in mm, okay. And C is the deformation factor in Newton per mm square, and EP is the modulus of elasticity of pinion, and EG is the modulus of elasticity of the gear, and PD is the dynamic load or incremental load in newtons, and PT is the tangential component of the force. This PT is the tangential component of the force due to rated torque, okay. So these are the things that you have to keep in mind. This PD factor will add here, and hence we can find out the actual force which is responsible for power transmission between the gears at higher velocities, by including the dynamic effect of the load, which will arise because of all these three reasons by using this equation. So this was all for today's friends, and if you like my video, you can subscribe to my channel and also press the bell icon for the notification of the upcoming videos. So thank you friends for watching the video.